Hello, Professor. Myself Nitish and my teammate is Sindhu. Our project is about wormhole detection in wireless sensor networks using spanning trees. So, the subtitle of this is a novel approach for an efficient WSN security. Next slide. So, Coming to the overview of this wireless sensor network, wireless sensor networks have become one of the most important technologies that support real-time data collections and communication in several areas. In a wireless sensor network, there are many autonomous sensor nodes. Each sensor node can locally perform certain tasks like sensing or processing and exchanging information using wireless communications. WSNs are found applied in domains such as environment, observational, medical care, and industrial automation, agricultural applications, operations, uh, and etc. These have some challenges like limited resources, security threats, scalability, fault tolerance. Wireless sensor networks play a vital role in applications like environmental monitoring, healthcare, smart cities, and industrial automation. And they provide a real-time data collection, analysis, and decision making, enhancing efficiency and safety. It ensures data integrity, availability, and confidentiality also. So we go to the next slide. In the security threats in WSNSR, some of the common attacks include eavesdropping, example, intercepting communications to gain unauthorized access to sensitive data, jamming, emitting, and next one is jamming. Jamming is like emitting signals to interfere with communication channels, rendering them unusable, and node replication, physical tampering or hijacking into a node to gain an access to the network. And wormhole attack is the attack which means an attacker can create a tunnel between two network points to distribute routing and mislead of nodes. We go to the next slide. The next slide is about a literature survey. In this, the traditional methods often require specialized hardware or synchronization, making them impractical in large scale WSNs. So distance based. Uh, the first one is the distance based in existing detection methods. The distance based is realized on measuring physical distances between nodes, and time to flight is measures signal propagation time to calculate the distance, and traffic analysis is monitors the traffic patterns to detect anomalies. These require extra hardware or precise synchronization and computationality expensive, especially for the large network. So proposed spanning tree based detection algorithm that is simple and computational efficient or requires only basic graph algorithms. So we go to the next slide. It's about spanning tree basis. A spanning tree is a subgraph of linked graphs that contains all nodes, but the only enough edges to keep connectivity without creating cycles. Simply, it connects all the nodes, has few edges and edges as feasible, guaranteeing that every node is reachable. Used for connectivity analysis. In wireless sensor networks, a spanning tree describes the network's basis topology. Every node interacts with other via network of connected edges, and the properties contains exactly n1n and n1 and ni. edges of our NNN nodes, provides a minimal communication path connecting all nodes. Using in net uses in use in network security are spanning tree reflects network connectivity, making it easy to detect disruptions caused by attacks like wormhole attacks. We go to the next slide. It's about a proposed solution: spanning tree based wormhole detection. In the step one, we can see the random deployment of nodes in 2D plane, and in the second step, we can see the introduction of wormhole attacked by creating a hidden communication link. In the steps three, we can see there is a construct a spanning tree using DPFs and BPFs and compare the expect and actual topology. In step 4, identify affect nodes based on anomalies in the tree structure. We go to the next slide. It's about system design. In the system design, we have the network deployment. It involves placing sensor nodes in a target area and forming communication links. Uh, and in wormhole attack simulation, malicious nodes are created and low latency tunnels to manipulate routing or disturb the network topology. The detection algorithm identifies such attacks by analyzing hop counts, delays, or topology anomalies using methods like TRT, RTT measurement or neighbor verification. And in the evolution method, we have like accesses the algorithm performance in terms of detection accuracy, false positives, and computational efficiency in realistic scenarios. So the next we go to the next slide. So the next slide is system implementation. In this, we can see in the first point, we have the implementation details developed using Python 3.x. Libraries used a network for graph based operations. Metapol using visualization, simulated use WSN with a random deployment, wormhole attack introduction, and spanning tree analysis. So the second implementation is testing environment. In this, the network of 400 nodes are randomly placed in 10 into 10 area, and communication radius of this is 1.2 units. And the third implementation is the challenges. In this, scalability issues in large networks and dynamic topologies. So the next slides will be continued by my teammate Sindhu. Thank you.
Hello, Professor. Myself, Sindhu. Coming to the algorithm workflow, the step includes the network generation, wormhole detection, spanning tree construction, and anomaly detection. Wireless sensor network operations begin with network generation, where nodes are deployed. The discover neighbors to establish the topology. A spanning tree is then constructed by selecting a root node and organizing nodes hierarchically based on the shortest path to the root. For wormhole detection, the network is analyzed for abnormal shortcuts or inconsistencies in hop counts and delays using techniques like delay analysis and topology verification. And the last point is anomaly detection. It monitors metrics such as traffic patterns, energy consumption, and communication behavior to identify the deviations, employing statistical or machine learning methods to isolate and mitigate the malicious or faulty nodes. Coming to the next slide, that is the demo part. Yeah, this is a demo part. The project represents a simulation of the wireless sensor network with 400 nodes randomly deployed in a 2D area. A wormhole attack is introduced. Uh, Yeah, this is a demo part. The project, this project presents a simulation of the wireless sensor network with 400 nodes randomly deployed in a 2D area. A wormhole attack is introduced by establishing a hidden communication link between the two distant nodes. The spanning tree-based detection algorithm analyzes the network's topology to detect these anomalies and identifies nodes affected by the wormhole. For this one, the system requirements are like the Python 3.x and the network X. This is used for the graph-based modeling for the sensor networks, and we have used the matplotlib for visualizing the network topology and detecting the results. To install the required dependencies, we have run the command bash pip install network x matplotlib. And coming to the files, we have the detect wormhole.py. This is the main script for simulating the wireless sensor networks, introducing the wormhole attack and detecting anomalies using the spanning tree based approach. And the next one is the network deployment.py file. This is responsible for the random deployment of nodes and defining the communication model for the network. And the next file is the insert wormhole.py file. This simulates a wormhole attack by creating a hidden communication link between two adjacent nodes in the network. And we have a README file. This is the documentation file providing for an overview of the project. Coming to this, we can run the file and here we can see the running detection from the root one and everything. And this is the output for the file. This is the output file. And coming to the presentation part, we are going to the next slide. That is the output of the file. That is a visualization spanning tree detection. Here it is displaying the spanning tree and the affected nodes across the various root nodes. Here the visualization, green represents the unaffected nodes, the blue represents the affected nodes, pink represents the wormhole nodes. One key observation from the visualization is how the wormhole attack alters the network spanning tree. As shown in this figure 1, the presence of the wormhole causes certain nodes to be connected in unexpected ways, creating a direct communication link between the distant parts of the network. These anomalies are clearly reflected in the spanning tree, allowing the algorithm to detect them. Yeah, coming to the next slide, that is visualization network topology. This figure visualizes the entire network topology after the wormhole attack has been introduced. Here there are pink and blue nodes that are affected ones, and the there is a wormhole effect. Malicious link distorts the natural network topology and detection. The spanning tree clearly shows a wormhole alters the network. In this figure too, the affected nodes are visibly highlighted, and the wormhole's impact on the network topology is apparent. The hidden communication path introduced by the wormhole disrupts the network's natural structure, and the algorithm identifies the node that are influenced by this change. This highlights the effectiveness of the spanning tree approach in detecting disruptions of the network topology, which traditional methods may fail to identify. Moving on to the next slide, that is the result evaluation metrics. The results demonstrate that the spanning tree based detection algorithm successfully identifies the wormhole attacks with the minimal false positivities. These are the performance metrics. Here we can see like the detection accuracy is of the 92%, the precision is 90%, the recall value is of 93%, and finally the F1 score is 91%. Here we can say that it shows the most effective nodes are detected with the minimal false positives. And moving on to the next slide, that is the discussions. Here the key observations are the high detection accuracy of the proposed method demonstrates its ability to effectively identify the wormhole attack in a variety of network configuration. The algorithm effectively detects wormhole disruptions in the network. And coming to the precise and recall, these are the high values shows that the algorithm is reliable and minimizes false positivities. And next one is the advantages. The spanning tree based method is more computationally efficient and highly scalable compared to other wormhole detection methods. This approach operates based on simple graph traversal algorithms such as the DFS and BFS, which are computationally inexpensive and can thus be implemented on most sensor nodes. Moreover, this is very suitable for large-scale deployment of the WSN since this approach does not require any external hardware or the complex measurements. And moving on to the next slide, that is the limitations and the future work. Coming to the limitations, it assumes relatively static network topology and it may struggle in a highly dynamic or the large scale networks. And coming to the future directions, we can integrate to the real time detection techniques and incorporating machine learning for more adaptive detections. Hybrid approaches combining spanning tree with the traffic analysis or the machine learning. This comes under the future development or future directions. Yeah, moving on to the next slide, and that is the conclusion. The wormhole attack detection in wireless sensor networks presented a new method using the spanning trees. It is efficient in computation, scalable, and with a high accuracy to detect the compromised nodes in a scenario where a wormhole attack exists. Results confirm the effectiveness with regard to different performance metrics, and which includes accuracy, precision, and recall, and also the FN score of the methodology. Further improvements may include the dynamic network handling and the use of hybrid detection methods. And lastly, thank you. Thank you for your time and attention today. We appreciate you taking time to learn about the approach of wormhole detection in wireless sensor network. Thank you.